Hello, you are welcome to my channel. In today's video, we are going to learn the operation and how to wire automatic alternate control for two motors. When the first motor works for some time, it will stop and the second motor will start. When the second motor works for some time, it will stop, then the first motor starts again, in that order. We have similar system in my company, but PLC does the operation. In this video, we are going to use relays and contactors and a single timer to implement the system. So let's get started. This is the control circuit. I am coming to do the wiring. After the wiring, I will explain this control circuit. Then we test the wiring. From the live, it comes to one side of the stop button. From the other side of the stop button, it goes to one side of the start button. From the other side of the stop button, it goes to terminal A1 or 13 on relay 1. We connect a normally open contact on R1 in power with the start button. We tap from the input side of the stop button to one side of the normally closed contact on the timer. This is the input side. This is the timer. 5 and 8, they are the normally closed. 8 is the common. I will connect it at 5. From the other side to one side of the normal open contact on R1, I will connect it at 8. From the other side, that is the 8, to normal open contact on R1, one side. From the other side to timer coil, pin number 7. Then I will tap from number 7 on the timer to A1. I will tap from the normally closed contact on the timer to normally open contact on R2. From the other side, it goes to normally closed contact on R3. From the other side of the closed contact, it goes to normally closed contact on K2. From the other side of the normally closed contact on K2, it goes to A1 on K1. We wire the normally closed contact on R3 in parallel with normally open contact on K1. We tap from the normal open contact on R2 to normal open contact on K1. From the other side of the open contact on K1, it goes to normally closed contact on K2. From the other side, it goes to A1 or terminal 13 on R3. We wire the normal open contact on K1 in parallel with the normal open contact on R3. We tap from the downside of the normal open contact on R2 to normal open contact on R3. From the other side, it goes to normally closed contact on K1. From the other side, it goes to A1 on K2. I'll tap from the normal open contact on R3 to one side of the normal open contact on K2. From the other side of the K2 normally open contact, I will connect it at K1 normally closed contact. Lamp 1 X1 will connect to A1 on K1. This is lamp 1, lamp 2. This is X1 cable. It connects to A1 on K1. Lamp 2 X1 will connect to A1 terminal on K2. It's left with their neutral cables. I am going to loop all the neutral cables together. Now I've connected all the neutrals together. This is the circuit diagram. When we press on the start button, this R1 will energize. When it energizes, this open contact will become closed to provide a hold on for the R1. This contact also closes. Then current flows through the closed contact on the timer, then through this closed contact on the R1 to energize the timer and the R2. The timer is an on-delay timer. So as the R2 is energized, this contact is closed. Then current flows through this closed contact, through this closed contact on the R3, through this closed contact on K2 to energize the K1. And then the lamp will also come on. When the K1 energizes, this contact will close to provide a hold on for the K1. At the same time, this contact on K1 will also close. When it closes, current flows through this closed contact, through this closed contact on K2 to energize the R3. At that same time, this contact on the K1 will also open. As the R3 is also energized, this contact is open. This contact is closed to provide a hold on for the R3. This contact is also closed. So over here, we have close, open. Why this one is open? Because the K1 is energized. Over here, we have close, close. Here, we have open and close. When the preset time is reached, this close contact on the timer will open. When it opens, the timer and the R2, they will de-energize. Let's see what happens here. As the R2 is de-energized, this contact is opened. Therefore, current will stop flowing through this line. In that case, K1 and the lamp, they will go off. When the K1 de-energizes, this contact is open. So we have open, open. This contact is also open. But because this contact is closed to provide a hold on for the R3, even if this contact opens, still the R3 will still remain energized through this closed contact. Let's see this contact. As the K1 is de-energized, this contact has gone back to its normally closed state. So now we have close, close. As the timer de-energized, this contact quickly went back to its normally closed state again. Therefore, we had a close contact, and the timer and the R2, they energized again. As the R2 is energized, let's see what happens this time. This contact will close. When this contact closes this time, let's see what happens. Current will flow through to this point. When it gets here, because the R3 is on, this contact is open. And because the K1 is de-energized, this contact is also open. So therefore, current can never flow through any of these contacts to energize the K1 again. In this case, it will find its way here. When it gets here, because the R3 is still energized, current will flow through this closed contact, on the K1 to energize the K2, and then this lamp will come on. As the K2 is energized, this contact is closed to provide a hold on for the K2. This contact, it will open. When it opens, this R3 will de-energize. When the R3 de-energizes, all the contacts on the R3, they will change their state. This contact will go back to its closed state. This contact will open. This contact will open. But when this contact opens, current will stop flowing through this line. But because this contact is too close, current will still flow through this close contact on the K2 to still keep the K2 energized. Now, the timer is counting. When the preset time is reached, this close contact on the timer will open again to de-energize the timer and the R2. So when the R2 de-energizes, this contact will open back again. When it opens, the K2 will de-energize. The lamp will go off. So as the K2 is de-energized, this contact will open back. This contact will close back. This contact will also close back. As this contact is closed, we now have a close contact, So now, when the timer de-energizes, this contact again went back to its close contact so quickly. So therefore, the timer simultaneously energized again. The timer and the R2, they energize again. So when the R2 re-energized, this contact closed again, and then the K1 came on again or energized again in that order. Until I press the stop button, the contactors will be energizing one after the other. This circuit is very useful in water pumping systems. Let's test the wiring. Because of demonstration, I have decreased the time setting to a lower value so that it will be switching faster. I am turning on the breaker. When I press on the start button, R1, R2, timer, R3, and K1, they would energize. Let's see the timer. Let's see this light. It goes on and off at the fastest rate. So you can increase the time setting so that the switching will not be that faster. When I press on the stop button, it will de-energize. When I press on the start button again to start, this circuit is used for pumps and mixers in industry. Let's say two motors are pumping water to a facility. What you do is, one pump will pump the water for, let's say, 30 minutes. After the 30 minutes, the first pump will go off, then the second pump will take over, so that pressure will not be on one pump. Let's look at these two motors that I am working on. They operate one after the other. The one that I am working on, it operates for 30 minutes, and the other one also operates for 30 minutes. So after the 30 minutes, the first motor, the one I'm working on, it will go off. Then the one over there, it will take over. So this is the same circuit. It is very useful in pumping systems, water pumping systems, sewage systems. Alright, this brings us to the end of today's video. I'll see you in my next tutorials. Thank you.